Okay, there's one or two little modifications on this question. If you just call them out again, I think we changed that to 15, didn't we? What else did we do? We changed that to 2 meters, was it? So that's 2 meters, and the other one is 15. Okay. Find the distance ED correct to one decimal place. Now, ED is located in which triangle? Sorry? It's bottom right. And what type of triangle is the one on the bottom right? It's a right angle triangle. Now, the way it works is cosine rule, sine rule, they always work, no matter what the triangle is. However, when you have a right angle triangle, it opens up SOHCAHTOA, and it also opens up the Pythagoras theorem. So which one would you like to choose? And why are you choosing Pythagoras? No, there's another reason. Come on, more specifically. The keyword two vertical poles on level ground. Check me. No, you're right. You're right. He's right. You need both yellow parts to specify that it's 90 degrees. You need A vertical and B the other part is horizontal. That's the only way we knew they were 90. Okay. Otherwise, we'd be lacking information then, wouldn't we? There'd be no way around it. There's no way getting any more information unless that is 90 degrees. Now we're going to Pythagoras theorem, and we get x squared equals 2 squared plus 10 squared. X squared equals 104. X is equal to, what's it, the square root of 104, which is 10.2. Okay, many people got 10.2. Okay, good. We're on a roll. Now, what's part 2? Find the angle AEB. Where is AEB located? AEB. A to E to B. This one here. We'll call it angle. Think of a letter. What do you want to call it? Angle A? K. Alright. Now, in that triangle where it's located, is it a right angle triangle or what is it? It is a right angle triangle, okay? So, if you redraw the triangle really quickly, you'll find that it's it's 15 up this way. Is that right? 15, 12 down, angle K. Yes. You can do, yeah. Sorry about that. Now, it's a right angle triangle. Am I allowed to use SOHCAHTOA? Okay, would I use SOHCAHTOA? If I use Pythagoras, what's the only thing I can get? Pythagoras would give me the length from here to here. The question specifically asked me for it's asking me for an angle. Okay? No, it's asking me for an angle. No such thing as the opposite. Opposite sides. I'm looking for an angle. Okay? So, if I choose Pythagoras' theorem, I find the length of a side. I'm looking for an angle, so I can't choose Pythagoras' theorem. It's impossible, right? Pythagoras' theorem will only give me the third side. I need an angle. So, I use SOHCAHTOA. I know that that's the opposite. That's the hypotenuse, and this one's there. Adjacent. We use cos k equals, remember SOHCAHTOA, cos is adjacent over hypotenuse, which is going to be what? 12 over 15. What's the only way to end an angle question, James? What button do we need to press? And what type of inverse are we doing for this specific question? Cos inverse, 12 divided by 15. And lo and behold, 36.87 rounded off to 37 degrees. Are we cool with that? Yeah. K equals cos inverse 12 over 15. We good? Now, go back up to top. Just gonna take this diagram with me. Huh? Oh yeah, yeah. Here we go. I'm just gonna sort of paste this over the top, just so we know what we're doing. Now, I'm just after finding out that the angle K is what? Oh, indestructible. Which was 37 degrees. We changed this to 11.3 degrees. What's CED, lads? A lot of people got this mixed up. C to E to D. Where's that? Where? C to E to D. I'm pretty sure it's this one here. 11.3 degrees. We could have got that anyway, couldn't we? We could have tan inverse 2 over 10. We could have used SOHCAHTOA to find that angle anyway. They didn't even have to give us that. Okay. Now what about the middle angle? The blue one. So 180 minus 37 minus, and what you get? What'd you say? 131.7, and I wouldn't give you full marks for that because it has to be to the nearest degree. 132 degrees. Okay. In fact, even in my own test I wouldn't have got 100% because I wrote 131.7. No, I fixed it. Now, you know, I never don't get 100, lads. That's just the way it works, you know. Perfect every time. Now, what did you say that was? 132? That's 11.3. Okay. Hence or otherwise, find the distance D to B. Everybody see D to B? I'm going to highlight it in green. That there, yeah? Now, on a really basic level, D to B is this triangle here. There's 132 degrees in between. Should be more obtuse. That's 15. That's 10.2. We're going to let X be equal to dB. Can anybody tell me now what you think we should do to find out what dB is? Can we use SOHCAHTOA? Oscar's ruled out SOHCAHTOA, guys. He said no, but I need a reason why I can't use SOHCAHTOA. Huh? Not a right angle triangle. Okay. I know, I use the sine rule. A over sine A equals B over sine B. Sine rule it is, lads, yeah? Sine rule works usually, doesn't it? Let's try it out. X divided by sine 132. 15 divided by sine nothing. We don't know it. Or we could have used 10.2 over sine. We don't know what the other two are, do we? So there's two different things we don't know in one equation. What does that mean about the sine rule? Sine rule's blocked. Can't be done. Because we don't know this and we don't know this. So in both cases it would be blocked. Okay? So now we go to the cosine rule instead. Cosine rule is this one here. Now in the cosine rule I'm going to highlight two key parts. Why have I highlighted these two parts? Huh? If you choose one of them, the other one's chosen for you. Okay? So which angle do you think you're going to use? 132. Now, when you choose that to be 132, the side that looks at the 132 is chosen as the A value. So what are we going to call A? So x squared. Now what about the other two values? B and C. 15 squared plus 2 squared minus 2 times 15 times 0.2. How does this question end? Does it end with cos inverse? Why not? What's the question asking you for? It's asking for your distance dB. Do distance questions end in sine, cos, or tan inverse? No, never end that way. So, therefore, you know that you're on the right track. You put all of that into the calculator and you find x squared is going to be, what's it, 533.79? Square root it, and we get 23.1. Many people got 23.1. Is that your 100 gone, is it? You got it, Farrell? Good man. Okay. The diagram shows a vertical tree. What's the significance of the word vertical? It might lead to a 90-degree angle. From a point C, which is here, on level ground, 38.5 meters from the base of the tree, the angle of elevation to the top of a tree A was measured as 44 degrees. Find AB correct to 2 decimal places. Okay, it's a length question, right? Everybody happy with that? It's a length question, which means it can't end in tan inverse, cos inverse, or sine inverse. Can't end that way. Okay. Second piece of information: can we use Pythagoras' theorem? To use Pythagoras' theorem, how many sides do you need? Do we definitely know the length of 2 sides? No. So Pythagoras' theorem is also a no-go. So what does that leave? SOHCAHTOA, because it's a right angle triangle. Now, what are the names of the 2 sides we know? This one's called E, and we're looking for the opposite and adjacent. Which one do we choose? You gotta be certain about this. Why is it TOA? And why are you dead certain? Yeah, okay. So you have the adjacent, you're looking for the opposite. TOA is the only choice. It's just a way of remembering that off. So tan 44 equals, think of a letter to represent the opposite. Okay. O looks a lot like 0, so I'm going to use X. Now that that's done there, what do you do with the 38.5? Bring it over in front of the tan. Okay. Anybody know what to do next? Just put in the calculator. 37.18. Everybody happy enough with that? Okay. Now, what happens in the next question is that the tree then becomes slanted. Okay. So the tree is damaged during a storm and it tilts at 26 degrees to the vertical axis, okay? And to stabilize the tree, a cable is attached to the tree 2 meters from A. So this is taken from a mock. So here to here, guys. See that green part I drew in there? What length is that? That's 2 meters. As specified in the question. It says that it's attached 2 meters from A and the other end is pegged to the ground at C. Okay? It also says that this is 26 degrees to the vertical. What does that mean about this angle down here? It's 116 degrees. Its length 26 degrees above 90. That angle there is 116 because it's 26 degrees bigger than 19, right? So 38.5. The question is asking me find the length of the cable correct to 1 decimal place. Find the length. Technically speaking, it wants me to find the length of the blue part, doesn't it? Does everybody agree with that? So if I find out the length of this here, and also what I do is I take 2 away from that answer, I find the length of the cable, right? Because it's pegged 2 meters away from A. So the cable is the blue part, from the blue part downwards. Okay. Now, is there any other piece of information I'm leaving out? What was the height of the tree? 37.18. Okay. Let's run through our system here, Deck. I want you to tell me what formulas I can't use. Why? Okay. It's not right angled. Yep, go for it. Why? Okay. What's my other choice? Sine rule, is it? Is this an angle or a length question? So, no, both of them can be used for angle or length. So, just a quick thing there, guys. See the sine rule and the cosine rule? They can both be used for angle and length. So that's not a distinguishing factor in your choice. Okay, they can both be used for angle or length. Okay, what we're going to do is we're going to try to make the sine rule. If we can't make the sine rule, we'll use the cosine rule. Are we able to make the sine rule? 116 over x and 116. Pick another side. 37.18. Do we know the angle opposite to 37.18? We don't. Huh? It's not 44 degrees. That's from the last question. So there's no angle to use. Therefore, are we blocked? We can't use it. Okay, it's no good. We have no angle to go in. So, some of you might have it learnt off is that you use the cosine rule when you have a sandwich. Side angle side. Do you see the sandwich that I'm talking about here? You know the side, the angle in between the other sides. That's a clear sign of a cosine rule. Or failing that, you can't make your sine rule. Okay, Lee, lead the way with this. What's your A value? Big A is 116. Okay, that's big A. And when you pick 116 to be big A, what automatically has to be small a? Whichever side that angle is looking at. What? It's looking at X. So the two yellow parts pick each other. And then after that? Excuse me, guys. Huh? Yeah. Plus. Yeah. Yeah. Two bracket both lengths, yeah? 27.1a and 38.5. Okay, put that in the calculator and let me know what happens. Not that anyway. Was it? Yeah, if it's rounded off, yeah. I got 64.184, which is 64.2. Is that my answer? It's, there you go. Take 2 meters away. Take away your 2 meters and you get 62.2 meters. That's because it's 0.3 off. I gave it to you, right? Oh, should have done that. Okay. So, it is decided to reduce the height of a different tree by 4 meters. Key word is what? Different trees reduce. Okay, now find the angle BTS. B to T to S. Top angle. Okay. Now, I always ask this question, okay? How many triangles do you see there? 3. You see the top one, the bottom one, and the big one that does the whole thing. I ask you to look at the big one, okay? Because BTS belongs in that one as well. And we also know that that's 90 degrees. We know that the two of them added together gets me Anybody? 50, which means that BTS up the very top must be 40 degrees. 180 minus 50 minus 90 gets me 40 degrees. BTS is 40 degrees. Okay. I'm just going to need that in a second. Now, that's BTS done. Moving on. Hence find SC correct to 2 decimal places. S to C. Okay. Now, S to C. Okay, that's not too bad. Okay. Should we use the cosine rule? We're looking at the very top here. Okay, we have to get S to C. So what I'm gonna say is, why don't we look at the triangle? This is just this triangle here on its own. So always draw them separately first. Just this triangle here. 12 degrees for this one here. 40 degrees up here. And we know that that's 4 meters. And we're looking for S to C, which we will call X. Any ideas how to work this triangle here? What rule we could use? Let's figure out what we can't use. Can't use SOHCAHTOA. Can't use Pythagoras' theorem. It's an angle or a length question. So cosine rule or sine rule. Is it a sandwich? So sine rule. So X over sine 40 equals 4 over sine 12. And then what do we have next? X equals 4 sine 40 all over sine 12. And what you get? 12.37. Okay, 2 decimal places. Now finally, part 3. Find BC, the height. Find the height BC, guys. BC. Now, anybody know how to find B to C? What rule do you want me to use? B to C is located in which triangle? The bottom one's a 90-degree triangle. It's 12.37 here. It's 38 degrees here. Now, the sine rule will get you the right answer, but generally speaking, we don't use the sine rule on right angle triangles. You can, but I'd rather keep us to what you should know already. Anybody remember SOHCAHTOA? Okay, BC. Thanks, Lee. Okay, we'll label BC as X. Now, what side is X? X is the opposite. 12.37? Hypotenuse. If you're using the opposite and the hypotenuse, which function are you going to choose? Sine. Okay, sine. Sine what, Declan? Sine which angle? 38 degrees equals? What's the opposite side? Over. Okay, after that 12.37 sine 38, and then finish it off then. We find out that X is in fact 7.62 meters.